Hello and welcome to AP Calculus Lecture 5.3a. You're going to need this note printout and maybe a highlighter as we go through this. So most of this lecture we're just talking about pre-cal concepts. If you had me for pre-cal, then you use some of these exact same notes. And in the very last page of the notes, we go into a little bit of calculus. Okay, so an inverse function undoes another function. An inverse function reverses the original function's input and output values. So let's take a look at our first example here, and we'll see what we're talking about. So for example, let's say we've got f of x is 2x minus 3, and then g of x is x plus 3 over 2. And I can tell you these two are inverses, okay? So let's find f of 1. So if we plug in 1, that's 2 minus 3, that's negative 1. Now if we plug in negative 1 into g of x, so plug that in, it should equal 1. Okay, so if we plug in negative 1, that'd be negative 1 plus 3, that's 2 divided by 2, and indeed it is 1. So if you plug the output of f of 1 into the input of g, then you're going to get the original input. Okay, so let's try another number. How about f of 3? So it should always work if they're indeed inverses. So plug in 3. 2 times 3 is 6, minus 3 is 3. Then we're going to plug 3 into g. And what should we get? All right, 3 plus 3 is 6 over 2 is 3. So that matches the original input. Let's try one more. Let's try f of negative 2. So if we plug in negative 2, that'd be negative 4 minus 3 is negative 7. And then we'll plug that output into g. So negative 7 plus 3 would be negative 4 over 2, which is negative 2, which matches our original input. Okay, so just on further, the next bullet on your notes there, if g of x is the inverse of x, then g of f of x, and I'll show you what I mean in a minute, is going to, when you simplify it down, it'll equal x. And f of g of x, when you simplify that down, it will simplify to x. Okay, they both have to work in order for the two functions to be inverses. So let's answer the question. Are f of x equals 2 over x plus 6 and g of x equals 6x plus 2, are those inverses? So first, let's find f of g of x. What that means is we're going to plug this entire function, this whole thing, 6x plus 2 over 6, into x and try to simplify it. So that's going to be 2 over 6x plus 2 over 6. So we plug that whole thing in as x right here, plus 6. All right, that's going to be the same as 2 over 6 will go into 6x one time, so x, and then 2 over 6 would be 1/3. So plus 6. All right, and that's 2 over x plus, so that's the same as 18 over 3, right? So 19 over 3. Listen, there's no way, I don't have to go any further. That does not equal x. You're not going to be able to get that So you could stop here. The two are not inverses, but we'll go ahead and look at the other side of it and do g of f of x. So that means we're going to plug in 2 over x plus 6 into this x right here. So 6 times 2 over x plus 6 plus 2 over 6. All right, so let's see. That's going to be the same as 12 over x plus 6 plus 2 over 6. And I'm going to tell you now, you can do all the work you want to on this. This is not going to simplify down to x. Okay, so those first two we looked at, are not inverses. Let's try another one. So you can probably guess, if I gave you one where they are not inverses, you can probably guess how this one's going to work out. But the next example, so we are at the bottom of the first page of your notes. We have f of x is equal to 2x plus 5 over 3. And then g of x is equal to 3x minus 5 over 2. So let's find f of g of x. So you're going to plug in 3x minus 5 over 2 into this x right here. So 2 times 3x minus 5 over 2 plus 5 over 3. So let's see if we can simplify that down. That's 2 over 2. Those cancel, right? And you just have 3x minus 5 plus 5 over 3. Negative 5 and positive 5 cancel, and you have 3x over 3. And the 3's then cancel, and then you just have x. So far, so good. We passed the first test. So let's look at g of f of x. We're going to plug in f of x into this x right here in g. So I have 3 times 2x plus 5 over 3 minus 5 over 2. So here, the 3 and this 3, those cancel. You have 2x plus 5 minus 5 over 2. That's 2x over 2, which again is x. So they are inverses. So the answer to the question is yes. All right, so you will be doing that on your first few homework problems. Finding f of g of x and g of f of x and seeing if they reduce to x. All right, let's turn now open to page 2 on your notes. So inverse notation, the inverse is written as f to the minus 1 of x. All right, that's not the same as the reciprocal of x. Even though the notation is the same, if you are in context and we're talking about inverses, the inverse is written as f to the minus 1 of x. So I'm going to remind you about the horizontal line test, which you learned about in both Algebra 2 and Pre-Cal. A function must pass the horizontal line test to have an inverse. We call it, if it does, a one-to-one function. So every x has one y and every y has one x. Okay, so leave space here. I'm going to draw 4 graphs. So our first example is just a line. All right, so we'll call this y is equal to f of x. So does it pass the horizontal line test? I'm going to use my marker as a horizontal line. It can only pierce the curve in one spot to pass the horizontal line test. So indeed, it does pass, we'll call it the HLT, horizontal line test. So it does have an inverse. All right, our next example. Well, I'm going to draw a good old-fashioned parabola. We have y equals f of x there. So does that pass the horizontal line test? Well, no. Not at least on the full domain. It pierces the curve in two places, so it fails the horizontal line test. So there is no inverse for this kind of function, a parabola. A function to the fourth power would also look like that. All right, let's draw another one. So we're kind of at the bottom of your notes here. Let's say something like this. So it looks kind of like maybe a cubic function. So does that pass the test? Yes, it only pierces in one spot, so passes the horizontal line test. So the answer is yes, has an inverse. And our last graph on this page, so let's just change it up just a smidge here and go like that. All right, and you can see as long as the domain includes all of x, we could cut it off right here and it would have, an inverse. And you can restrict the domain, but we're not restricting the domain here. So this function fails the horizontal line test. So there is no inverse. All right, so that does it for page 2 of your notes. So over to page 3. So you see we're going to draw some more graphs here. Identifying inverse functions graphically, the inverse point, so we're just talking about a point here on the graph, is a reflection across the y equals x line. So the y equals x line is that 45-degree line that passes through the origin. All right, graphs of inverse functions have reciprocal slopes. Okay, so let's do these graphs. All right, so I'm going to draw the line. We'll do it as a dash line. The line y equals x. Okay, and let's have A, point B, and then we'll call this point B and point A. Okay, so at the point BA, so over B, up A, let's say you were to put some wet paint on that point. And then you were to take this, let's say this was on paper, and you could fold it over, all right, across this line, y equals x. Where would the paint leave a mark on the other side? It would leave a mark at the inverse point, at the inverse point AB. So think about it as folding across that line. So we would call this a reflection across the line y equals x. That's all an inverse point is. Okay, and the same thing, also an inverse function. So let's draw another one. My axes aren't very straight today. We'll do our y equals x line. Always like to make it dashed. All right, I'm going to use some different colors here. So let's say f of x, we'll make it red. So this is f of x there in red. If we were to fold now across this paper, let's say it's paper, across the line y equals x, we would get the inverse function, a graph of the inverse function. And they are going to cross each other right here at the line. And it would look something like this in green. And we would call that f to the minus 1 of x. That's our inverse function. All right, let's do another one. So let's say we have f of x equals x cubed. So first let's draw the line y equals x. All right, f of x equals x cubed would be something. All right, we'll do this in red and green. So that's f of x equals x cubed. Our inverse function, if you were to map the reflection points, fold across the line y equals x, if you painted that, the inverse function would look something like this. And that's going to be x to the 1/3. All right, so just to give you an idea what inverse functions look like graphically. So the last bullet, and we're not going to do these on the calculator. You are welcome to do that on your own if you want. A function can have an inverse over a particular domain. So if we restrict the domain, but not its entire domain. So you can, and I think the homework does this maybe in 1 or 2 problems, restrict the domain so that it passes the horizontal line test. Okay, I mentioned that when I drew on the last sheet when on this function right here. So for example, if we restricted the domain to say from right here at the very bottom to the right, then it would pass the horizontal line test, wouldn't it? So if we restricted it to whatever this value is and to infinity on the right, then it would pass the horizontal line test. It's only the parts that fail the horizontal line test that you don't have an inverse for. Okay. Well, now we'll get kind of into the algebra of it, of inverses. Finding inverses algebraically, what we're going to do, hopefully you remember this from pre-cal, it'll ring a bell. We're going to swap the x and y variables and solve the new equation for y. All right, if it cannot be solved for y as a function of x, then it does not have an inverse. All right, so I'll do an example of one that doesn't have an inverse in a minute. But our first example is find the inverse of y is equal to 4x minus 3. So let's swap the x and the y. So we'd have x is equal to 4y minus 3. And now we're going to solve for y. So add 3 to both sides. X plus 3 is equal to 4y. So x plus 3 over 4, divide both sides by 4, is equal to y. And that works. That's a one-to-one function. There's no plus or minus here, right? So that is our inverse function. Another way to write this would be y is equal to 1/4 x plus 3/4. That's the same thing, right? So you know your y-intercept is 3/4 and your slope is 1/4. Okay, let's do another example. Find the inverse of y is equal to minus 6 over x. So let's swap. X equals minus 6 over y. And then solving for y, you would just swap again. So y is equal to minus 6 over x. So in this case, f of x and the inverse are the same. That's pretty cool. All right, let's do one y equals x squared. Now you know, what's the shape of y equals x squared? All right, it's a parabola. So it's going to fail the horizontal line test. All right, so let's swap. We have x is equal to y squared. And now solving for y, you have the square root of x is equal to y, but it's actually plus or minus, right? Because anything that you square, let's say we square -2, that's going to be 4. If we square 2, it's going to be 4. So it's not one-to-one. We have no inverse. It's not a one-to-one function. Okay, because you have more than one x for each y. Okay, so last example, let's say we have y is equal to x cubed minus 7. So we're going to swap. X is equal to y cubed minus 7. Add 7 to both sides. Remember, we're solving for y. So the cube root of x plus 7 is equal to y. And that is the inverse, because odd roots are odd exponent are one-to-one. It's those even exponents that'll get you. Okay, so 2, 4, 6, 3, 5, 7, you're only gonna have, because you can have negative when you cube something, right? You can get a negative answer. Whereas you square something, you can't. All right, so we're gonna move to page 5 and do the calculus. So the calculus harkens back to the first part of chapter 3. So the derivative can be used to see if a function has an inverse. Functions that are always increasing or decreasing are one-to-one and have inverses. So examining the derivative can identify functions that are always increasing or decreasing. We're just going to do a sign line. If a function is always increasing, its derivative will always be increasing, and vice versa. All right, so we're just going to do a sign line, And if it's always increasing or always decreasing, then you know it has an inverse because it passes the horizontal line test. So let's do example 50 on page 336. So here we have f of x equals x cubed minus 6x squared plus 12x. And we want to see, does this function have an inverse? Let's evaluate the derivative. So that's going to be 3x squared minus 12x plus 12 equals 0. We need to find the critical point. I'm going to factor out a 3 here, and we would have x squared minus 4x plus 4 is equal to 0. And let's see if we can factor that to find our critical point. How about x minus 2 and x minus 2? So we have one critical point at x equals 2. So let's do a sign line. Let's plug in a number to the left of 2. How about 0? So you plug in 0, I've got a negative times a negative, which is positive. And how about, I don't know, 10? Positive times a positive, which is positive. This function is always increasing. So therefore it passes the horizontal line test and has an inverse. So if it were always decreasing, it would also pass the horizontal line test. But if you do a sign line and you end up with something like this, or you end up with something like this, both of those would fail. So there would be no inverse. But in the particular example I gave you, yeah, you do have an inverse. It's always increasing. Okay, let's talk about the homework. So if you'll take a look in your book at page 335, we're going to do 1 through 7 odd. And on those, you're going to prove that they're inverses. Don't worry about graphically, just do part A. And you're going to find f of g of x. So you're just going to see, does f of g of x equal x? And g of f of x equal x. Okay, so you're going to do the plug-in, simplifying. They should, if they are inverses, boil down or reduce down to x. Okay, 1 through 7 odd. You're going to do 9 through 12, all of those. Those are just, you just look at the graph and think about the y equals x line and try to match the inverses there. Okay, so for 13 through 23 odd, this is going to be, you're going to find the inverse if it exists. And that you're going to use the procedure from page 4 of notes. That's the swap, the x and the y and all that. All right, so find the inverse using the procedure on page 4. So let's see, 37 through 40 all. On those, you are going to just going to eyeball that. Does it pass the horizontal line test? All right, and give your answer on that. 41 through 45, that I want you to graph on your calculator and state whether or not it has an inverse. Okay, so does it pass the horizontal line test or not? And then finally, and this homework assignment isn't nearly as long as it looks, 47 through 51 odd, you're going to use the procedure on page 5 of notes. You're going to use calculus to determine if it has an inverse. Now there's one that seems to give students trouble every year, so let me give you a hint. On 47, a and b are just constants. So what's the derivative of a constant? All right, so when you take the derivative of this, think of a and b as just constants. You know, you can even make it a number, make a 5, you know, make b a 3. It doesn't matter. When you take the derivative of it, you know, what happens to a constant? So think about that because you're going to have to take a derivative for all of these and find critical points. All right, that does it for this lecture, and I will talk to you on the next one.